Okay, let's solve a mystery. It's about an element that's all around you, but you've probably never even thought about it. Go ahead, take a deep breath. Almost 4/5 of the air you just inhaled was nitrogen gas.
But here's the weird part. This super common gas is famous for doing, well, basically nothing. So what gives?
To figure this out, we have to look at how nitrogen atoms actually hang out together in the air. See, nitrogen atoms don't float around alone. They always travel in pairs, forming a diatomic molecule. And that connection between them, it's one of the strongest bonds in all of nature. They're locked up tight. It's called a triple bond. That's 3 pairs of electrons holding them together, and it's incredibly hard to break.
How strong are we talking? It takes a ridiculous amount of energy just to pry these two atoms apart.
But here's the problem. All life needs nitrogen. It's literally in our DNA and proteins. We can't use it when it's locked up like that. So, how on earth do we break that bond? For centuries, this was a huge problem, until a world-changing invention came along in the early 1900s. It's called the Haber-Bosch process. It uses intense pressure and heat to finally crack that powerful triple bond. The impact is just mind-blowing. This one process is thought to feed about half the entire world.
But unlocking all that power revealed a pretty shocking new side to this otherwise quiet element.
Turns out the same chemistry that makes fertilizer also makes powerful explosives like TNT and nitroglycerin. And this duality is seen in the inventor, Fritz Haber, a Nobel Prize winner who also pioneered chemical weapons. Okay, but nitrogen also has a cooler side. Literally, if you chill it way down, it becomes a liquid. At a super chilly minus 196 degrees Celsius, it turns into liquid nitrogen.
This extreme cold is used for everything from quick freezing food to cryotherapy and preserving biological samples. So, let's go back to our original mystery and put all these pieces together, shall we?
The reason the nitrogen in the air is so unreactive is simply because that triple bond is just so incredibly strong. And figuring out how to break that one bond, well, that changed everything for agriculture and for the world. Next up, we're talking about an element that was predicted decades before it was ever actually discovered: technetium.